All right, so I wanted to do, as promised, a little video showing working out the issue of this destroyer and its missiles, and convince you that even though enemy 2, I'm going to call that Cannonball 2, even though Cannonball 2 is going to be in the air for a much shorter amount of time, it can go a lot further. And also that it's going to get hit first. So I basically Googled, like, how fast can a cannonball go? And then used a speed about that. I got around 900 meters per second. I chose 2 angles for the initial velocity. I said that the cannonball one is going to be at 75 degrees, cannonball number 1. And cannonball number 2, I said, was at an angle of 20 degrees. So on here, this is 20 degrees, and then this is 75 degrees. All right, so basically what we want to look at is the time in the air and also the range, and compare the two. The first thing I need to do is I need to know the initial x and y velocity. I'm doing cannonball number 1 first. That's its angle of inclination, or angle of its initial velocity vector, is 75 degrees. All right, so the initial x velocity, you can see of that one, is relatively small. It's 233 meters per second. Its initial y velocity is 869. So you can see it has a lot of velocity initially in the y direction. I'm going to write my equations up here because I said I want you to do this, so I should do it too. These are my general equations, and I'm going to So those are my general projectile motion equations that I'm going to use. You can just see I put in v naught x and v naught y. I have those. I'm going to say that x naught is equal to y naught is equal to 0. Just keep it simple. So the first thing I want to know is the time to reach highest point. And we know that that will be when the Vy is 0. Vy is equal to V naught y, which is 869 minus 9.8 t. So our t is going to be 869 divided by 9.8, and that ends up to be 88.7 seconds. Now, because of the fact that we're assuming the cannonball starts and ends at the same level, we can say that the time of flight is just 2 times this time, 88.7. And so the total time it's in the air is 177 seconds, which is about 3 minutes. So probably a lot longer than you thought. This is for entire flight. And this is for to highest. So let's use those 2 times and figure out how high cannonball 1 will go and how far it's going to go. So if I plug in my numbers and do all my math, this should be 38529 meters. It goes pretty far. It's going That's how far it goes. Well, that's how high it goes, sorry. Its range, which is the x value, would be v naught x times the time of flight, which is 233 times 177.3, and it actually ends up going 41,311 meters. So that's how far it goes. So it actually goes it goes a little bit further than it goes high. And so that's the information for Cannonball 1. Now I'm going to do Cannonball number 2. I'm going to try to squeeze it in next to it just so we can compare it easier. That's the angle that's 20 degrees. So for Cannonball number 2, that's this guy right here. V naught x is equal to 900 times the cosine of 20, and that is 846. V naught y is 900 sine of 20, and that's 307.8. Okay, so right away you can see that the initial x and y velocities are sort of inversed in terms of the x velocity for Cannonball number 2 is much, much bigger, kind of like how the y velocity for Cannonball number 1 was much, much bigger. And then the same thing can be said if we compare the y component of the initial velocity for Cannonball 2 is more reminiscent of the value for the x velocity of Cannonball number 1. So once again, we're going to find the time to get to the highest point, which would be 307.8 minus 9.8 t. Look at the time when that is 0, so t to the highest point ends up to be 62.8 seconds. So you can see that's like a good 20 seconds less. Oh, sorry, I wrote down the wrong number. It's 31.4. Not only is it less, it's a lot less. It's less than half as big. I had written down the whole time of flight by mistake. So the time of flight, which is 2 times that t, that's the one that's 62.8. So you can see right away that the amount of time that Cannonball number 2 is in the air is much, much less. Remember that for Cannonball number 1, and that's this value right here, it was almost 3 minutes, and for Cannonball number 2, it's more like 1 minute. So big difference between those two. How high does Cannonball number 2 get? Its maximum height, if I put in the value, the 31.4 seconds, is actually 4,836. It's much, much less than the value I got for Cannonball number 1. And then what is the range? I would use the 62.8 times the higher velocity, and the v naught x is 846 times 62.8, and the total distance that this one goes is 53,129. So again, this one is much bigger than this one. So you can see there's a huge difference in their heights, but even though Cannonball number 2 is in the air almost like a third of the time that Cannonball number 1 is in the air, it actually goes further. So hopefully the numbers help you see that this is possible, that with the same initial velocity but very different angles, the shallow angle ends up being in the air a lot less and than the one that's at a steeper angle, because the steeper one goes higher in the air, so it's in the air longer.